Welcome in the next unit of this course on observation theory. In the past weeks you learned about estimation, and by now you know how to get an estimate of your unknown parameters, which is optimal or best. The criterion for optimality was chosen to be the minimization of the mean squared estimation errors. But so far we have not looked further into those estimation errors. No doubt, however, that presenting just an estimate of the parameters of interest in general will not be satisfactory without a proper quality description. How good is your X hat? Think of the farmer who had to know the width of the canal such that he could build a bridge. Of course, he wanted to be sure that the error margins of the estimated width were small enough, since a large error margin would mean a high chance that the bridge would be too long or too short. Some other examples where a quality description is very important. Think of an airplane using GPS to estimate its position, and assume the pilot is relying completely on those GPS positions to land the aircraft. All people on board will definitely appreciate it when the estimated positions are then within certain error margins to guarantee that the plane will hit the runway, like in this picture. Here the error margins are such that you can be almost sure that the true position is within the orange area, whereas here there is a big chance that the plane lands somewhere besides the runway. Another example. The Dutch government wants to know whether the dikes in the Netherlands will be high enough considering the ongoing sea level rise. If the estimated sea level rise is 3 millimeters per year, what is then the chance that it will in fact be 5 millimeters per year or more? Also here it is important to know the error margins that come with the estimated value in order to make the right decision. Should the dikes be increased in height or not? Those error margins depend on the different types of errors in the measurements that were used to estimate the parameters. Recall from week 1 that we distinguish between random errors, systematic errors, and outliers. The question is now, how do these errors propagate in our estimation results? And once we answered this question, what can we say about the quality of our estimation results? These are the topics of this unit.